Hello guys, welcome back to my channel. My name is Asan Khurram, and in this channel I teach you programming skills in Python, MATLAB and R programming. I also teach Tableau, a data visualization tool. So those of you guys who actually don't know me, I'm a data scientist. I have been providing freelance services in data science for the past 5 years. I have also been certified by Illinois Giles College of Business, where I actually get my training how to do the financial analysis, business analytics and so on. So it's been my great pleasure to actually teach you about today's topic, which is actually the time series plots in R programming. I have a lot of requests from my subscribers. They actually want me to teach them time series plot in R programming. So what is actually a time series plot, you may ask? So a time series plot is a graphical representation of data points collected or recorded at specified time intervals. With the help of R programming, we will do the effective time series data visualization, where we will be able to actually visualize the time trend, the seasonality that we can actually see through the help of data visualization, specifically for time series data. So why we use R for time series analysis, okay, or time series plot? So R is a powerful statistical programming language with excellent libraries for data visualization. R is ideal for creating time series plots by the use of libraries such as ggplot2. It has a great statistical capabilities beyond its data analysis or data visualization capabilities. And our scripts are highly reproducible, like it is applicable to one type of data set. You might be able to implement it for the other type of data set with the minor adjustments and tweaks. So let's move on and actually jump towards our practical programming section. So the first thing we have to do is actually to import our necessary libraries. The two libraries we are going to use is ggplot2 and quantmod. ggplot2 is actually used for data visualization, and quantmod is actually used to fetch the finance data, which is actually a time series data by itself. Okay, so got it? Two libraries, ggplot2 for data visualization and quantmod to fetch time series data, finance data or stocks data. Okay, so once we import the library, we are going to use the function get symbols of this library quantmod, and we will pass a number of input arguments that will actually help us fetch the right amount of data. Here in our case, we are fetching the Apple stocks data for a specified duration, and we are fetching it through the Yahoo financial data source. So that's why we are passing a number of input arguments. The first input argument to this function get symbol is AAPL in the form of string, which actually defines what kind of stock or what stock data we actually want to take. So AAPL actually is a synonym for Apple stocks data. Then we are SCR, which stands for the source is equal to Yahoo. So we are fetching data from the Yahoo Finance, and then later on we are defining starting date and ending date with the help of key value pair. Form is equal to specific date and to is equal to specific date. Once we done that, we were able to get a time series object which is called AAPL. Let me show you in this environment. As you can see there, this is AAPL. We are able to get it by through this statement here, and it is a time series object in the form of XTS. Okay, the next thing we have to do is actually convert that time series object into data frame. So we are calling first of all, we are declaring a variable AAPL underscore data, and we are using this function data.frame to actually convert that data convert that time series object into data frame. And we are doing an additional input kind of operation here. We are actually creating additional column out of this AAPL. That additional column is actually the date. Okay, so we have like the first column will be the date that is extracted from this time series object by the use of this statement index. And after that we are setting comma, and this is like a horizontal concatenation, and then we have AAPL data. Finally, we are using head function to actually display some of the values. So now you can see that the first column is actually the data. Then we have a bit of values like open, high, low, close, volume, and one other thing. So open is actually is opening stock price, high is the highest price of the stock at that particular day, low is the lowest price of the day, closing stock price, number of share traded, which is for the column volume, and adjusted is for adjusted closing price. Okay, so let's move on and actually jump towards our practical programming section, where we use ggplot2 library to generate a time series plot. So this is the basic notation of ggplot2. We will call the function ggplot, and first thing we have to do is to define the data and do the static mapping. So our data in our case is aapl underscore data, and in order to define the static mapping, we will define what data will be on the x-axis and what data will be on the y-axis. So obviously x will have the date, because we want to see the time series trend, and y would be any column base out of whatever the columns we have here. So we are setting the closing price, so we use aapl dot close. Okay, so this is the column name. Now once we done that, the next thing we have to do is to actually tell this ggplot what kind of chart we want to visualize. In our case, we want geom underscore line, which represents the line plot, and we are passing one input argument that we are setting the color, it's to be blue. And finally we are using labs in the form of here, and after round bracket we are passing three input argument, the title, the x label, and y label. Okay, which is like Apple inc stock closing prices, and the duration like 2018 2023. Then on x-axis we have day, and on y-axis closing price. Then with the use of addition sign, we are defining theme minimal, and after that we are defining some additional elements of the theme, that is we are some kind of tweaking the text of the title, the text of the x label and y label. Okay, now that being done, this is what our plots will look like. This is a time series plot, and you can see that it shows us the trend of closing prices over the course of time from 2018 to 2022. So let's move on and actually do some advanced data visualization for our time series data. We will first calculate the moving averages. Okay, moving averages help smooth out short-term fluctuations and highlight long-term trends. Okay, so basically what I'm going to show you right now in time series plot, how you are able to visualize multiple lines, multiple data in a single plot. So in order to do that, I have created an additional set of columns. We can see that here, APL underscore data, and with this dollar notation, this is like the column name, the new column name I'm defining. Let me just, please allow me a few minutes, so I might just reconnect to it again. Okay, so like the two additional columns are MA underscore 50, MA underscore 50, which actually represents the moving average over 50 days, moving average over 200 days. And in order to calculate the moving average values, what we are doing here, we are calling the function roll mean. Okay, and we are passing number of input arguments. The first input argument is actually the column we actually want to calculate the moving average of. So in our case, we are calculating the moving average of close column. Okay, so this is the first column data, and after that we are defining what would be the value of the what would be the date of that you actually want to calculate the moving average value, like what will be the number of days. So in our case, we are setting it to 50, and fill is equal to NA. Okay, in the same way we'll calculate the moving average for 200 days. Okay, so by doing so, we will smooth out stock price fluctuation by averaging prices over a certain number of days. Okay, so 50-day MA means the average closing price over the last 50 days, and 200-day moving average means the average closing price over the last 200 days. Now once we have calculated generated our additional columns, let me teach you how you can generate plot multiple lines on a single plot. So we have like ggplot, and the first thing we have to define the data and a static mapping. So we have like data, then a static mapping, AES is equal to date. just keep that in mind. We are not defining the y-axis because in this case we are actually defining multiple lines, so we have to define that in upcoming additional input arguments. So once we define the data and static mapping, so this is where I will define the number of lines. So in order to generate lines, we will use geom line, and you can see that within the round brackets I am passing the input argument which is aesthetic mapping, and here we are telling that y is equal to specific column a is close, and here we are also defining the color of legend. So basically it means that every line that would be generated will have a different color, and the legend will also be able to show it here by the use of this color is equal to closing price. We will repeat the same set of input argument for the remaining column like MA50 and MA200. Once we do that, we will use labs and we will define the title, the X and Y labels. Once we do that as well, here we are going to define some manual coloring to the lines. Okay, instead of like letting this ggplot library choose its own color, we are actually defining our own colors. Like for closing price we are on blue, for 50 MA we are orange. So this is how do we do that. Scale color underscore manual values is equal to C. Then we have key value pair definition here, and finally the rest will remain the same. And finally we are telling that we want legend to be displayed at the bottom. Now once we done that, you can see this is how the plot will look like. So this is kind of an advanced data visualization you will have for time series analysis, where you are actually able to spot or see the closing price over the time, but you are also able to see the moving average over 50 days, over 200 days, or any moving average day you want. Okay, so that's it. Now let's move on and actually discuss about some additional calculation that we might be able to do for time series analysis when it comes to financial analysis. The one important factor that everyone is kind of interested in or every broker is called volatility. So volatility is the measure of how much the stock price fluctuates, and it fluctuates on a daily basis. So we might as well want to calculate that volatility for our closing stock prices. Okay, so how we are going to do that? Obviously the approach will remain same. We have to create an additional column. In this case we are creating an additional column daily return in the data frame AAPL underscore data, and after that we just going to set we are using this statement here, which is basically a calculation that will actually calculate the volatility. And how is that calculation is performing? First of all, we are using diff on that specific column. So we are using function diff on the specific column, and what does function diff do? It computes the difference between two consecutive closing prices, like we have on one day 1 and day 2. So it will calculate the difference of that thing. And this statement here, like which is kind of a multiplied divided by this statement diff, takes all the closing prices except the last one. Okay, you can see that here we have this specific column data, and we are actually marking the data all the values except the final one. So this is like the formula to calculate the volatility in the form of percentage change. And here NA in this function will help us ensure that obviously there is no previous day price for the first day. So in that case we have to set its value to NA. Now once we have calculated that, the rest will remain the same. We will use the same ggplot notation, geom plot line, labs, theme minimum, and theme elements. So this is how the plots will look like. So we have on x-axis we have daily return, we have date, and so on. And in the same way, just we have plotted geom line. We can use use geom histogram and actually plot the histogram of this daily return. Like we would like to see what is the frequency of daily returns over the course of this year. So in our case, we can see that mostly the daily returns are quite close to 0. And do we see that the daily returns actually follow a normal distribution, that we see that it kind of has the same distribution for positive value and form distribution for negative value. So that's it for today's tutorial. I hope this tutorial have been helpful. If you have any question regarding today's tutorial of financial analysis, feel free to write down in comments. I will be happy to help you out. Thank you for joining me, and I will catch you soon in the next video. And I also offer freelance data science services and provide one-to-one tutoring services, so you are able to understand and excel programming. So thank you for joining me, and I will catch you soon in the next video.